Now on the inside install, we did this probably when we had our first outdoor wood boiler, and so I don't know, it took me a little while. Our house is 3 stories. We're actually in the basement now, so we have to push water all the way up from the basement into basically the first level, and then all the way to the kids' rooms. So we actually did our system is a closed loop system on one side, and then an open loop system on the other for the outdoor boiler. So I'll show you kind of what this is done. And we did all this work ourselves. We don't really hire anything out much around here, so I pretty much designed this entire system and soldered all the pipe and ran all the pipe and did all the plumbing, etc. myself. So let me show you what the system looks like that we did. Yeah, okay, it looks like a rat's nest, but let me explain a little bit about what's going on here. So this is the area where the hot water is coming in from the boiler. What I do is I actually run it through a filter, and then I have a bypass because you won't get enough flow through this filter, so you just do a bypass and crack it. So some of the water goes through the filter, some of it bypasses around. Then the piping comes down into our heat exchanger, and basically it goes through a plated heat exchanger, and then returns back here to the boiler. And I put some temperature monitoring stuff on it just because I'm curious with the data and how much heat transfer is actually happening. So that's that side of the system. So that's an open loop system where that's constantly going back and forth to the boiler the entire time. Now for the part that's on the house, the heat exchanger obviously transfers the heat from the outdoor wood boiler to here. This is a closed system, meaning that it's pressurized, and essentially we've got this pressurized such that the pressure is what actually pushes the water, from my understanding. I'm no expert on this hydronics, but from what I understand, the pressure, which is, I can't remember if it's 10, 15 psi, I can't remember, but the pressure is actually what pushes the water up you know, to that, from the basement it would be considered the 3rd floor of the house, and then the circulator pump just moves the water. So essentially it's pressured here through that regulator, which is tied just to the main water line of the house. It goes through the heat exchanger here. This is the circulator pump that just circulates the water. Of course, you don't want to have any air in the system, so I put in a air separator, and then safety from a valve. One thing that I messed up, I didn't realize, is that in closed loop systems you kind of get this black film over the time, and that can kind of cause, you know, your plate heat exchangers to corrode or really stop up and stop the heat transfer. So I actually come in, and this really solved the problem. So this is actually almost like a magnetic filter. So it collects all of that black stuff that would normally corrode the inside of your pipes into this, and I just clean it. I pull that out, and it's a magnet, and I wipe it off. Then another kind of system like we had before, where filter bypass. Then this comes up, and then I have a zone controller. So essentially we got multiple zones in the house. So we've got a 1st floor zone, and this is controlled by that thermostat. 2nd floor, and that's controlled by that thermostat, and as you can see, it's calling for heat right now with the green dot. We actually have a hydronic heater in our garage for our Great Danes and our dogs, so they can sleep warm in our garage. This is for the hot water heater, and I'll show that at the hot water location here shortly. But that just runs continuously. I just let it run right to the hot water heater all the time, and we'll go through that in a minute. And then this is a small thermostat we have in the master bath that actually, when we were doing this, we ran the coils back and forth right underneath the floor of the master bath, so it heats the tile. So it's nice on cold days, cold nights. cold mornings when you get up and you step on your tile and it's nice and warm. And then so this is going to all the units, wherever the things are going, and then of course the returns here, and then it cycles back around. So to give you a little bit of a temperature wise what's going on, so right now the water coming in, you know, we're sitting somewhere around, these are not 100% accurate, so it's hard to say. I use this digital thermometer, which is nothing but a remote transmitter barbecue grill, and I put basically a probe and taped it up to here to kind of monitor the water coming in from the boiler. And then I have that other unit upstairs where we're at, so at any point in time I can see what the water temperature of the boiler is. So that's how I kind of know when I need to go fill the boiler up. And you can actually set alarms so it'll start going off or beeping when it reaches a certain level or something. So we basically come in, this looks to be about 160 degree water temperature or so coming in. It goes through the heat exchanger, and then it's coming back out at, according to that, somewhere around maybe 145. So we're pulling about 15 degrees out of the water with this heat exchanger for what is calling for heat, etc. And you can see on the return loop here we've got roughly, you know, 150 degree water temperature here. It goes through the heat exchanger and comes out, and we're sitting at about 160, pretty close. So I mean, it's almost the same. That, you know, that heat exchanger really does well, and that we got close to 160 degree water temperature coming in from the boiler, and on the house side what's leaving is about 160 degrees. So, but anyway, yeah, so we designed all that, and of course we got the zone controller. That's where all the thermostats plug into, etc. But yeah, kind of designed all this and built it, labeled everything, left some opening spots. I actually had originally intended that, you know, we could actually heat the pool with this, so we just never done it. But we did when we did bore the hole through the concrete foundation, etc., to put this in. I did go ahead and do too, so if I wanted to get outside for a pool heat exchanger I could, but there again, that was 10 years ago, and today we're still not doing it, so I doubt it happens. We just don't use the pool enough. We did when the kids were small, but not now. So yeah, that's the system, and of course the expansion tank, and I pretty much figured up everything I needed, and honestly I just ordered all this stuff offline. I think I went through Plumbing House or something, I can't remember, it's been too long ago. But it's been a pretty good system. I did have to change out that heat exchanger last year. That's kind of why it's, you know, looks a little different. I had to cut and redo that, and a lot of that was because not knowingly about the corrosion that happens in closed loop systems and things like that, and I didn't have that magnet filter in there. We started losing that heat transfer capability, and it caused problems, but I think we got it corrected now. So all right, let's go over to the hot water, and I'll show you how we heat it all hot water. All right, excuse the mess, but here's what I do with the hot water. So basically this is always continuously flowing from where we just left a while ago over at the manifolds, and so this is coming down to this plate heat exchanger. And essentially what I done was I did add a filter in here when we changed out the hot water heater, just because I just like to put filters in things. Keeps everything flowing. That way you don't have anything potentially stopping up your plate heat exchangers. There's a circulator pump at the very bottom. It's basically monitoring the temperature. You can see that thermocouple that's on that. It's just a switch you buy and tie it into the pump, and when the water temperature reaches a certain, or the temperature of that pipe reaches a certain level, it kicks that circulator pump on, which takes the cold water from the bottom of the hot water heater, circulates it through the heat exchanger, and then is fed back into the hot water heater. And then of course what we do is we come off the hot side, and I did put a mixing valve in for safety reasons, etc. That goes to our hot water heater. Now for our forced air unit, how we provide heat to the house, think of it as a car with a huge radiator. So here is our, basically our inside unit, AC unit. It's a heat pump, but basically above it, cut it, and we put in the I don't know if it's called a radiator or what it's called, but it's a water to air exchanger, basically. So think of it as like a radiator. So when the fans call for, the thermostats call for heat, the fans come on, that valve over there turns on, which allows hot water to flow in through this radiator and around, and as the air is blowing through it, it's blowing hot air up into the house. So this same type of deal is upstairs in the attic for the second floor, but that's how the heating is done. And I think that pretty much covers the inside install and everything that we've done. And like I said, we've been doing this, using this for, gosh, I don't know, 10 years or so, maybe even longer than that. And you know, I love it. Yeah, it's more work, but like anything else, it's work. But I mean, it's nice to not have the heating bills. You know, with the farm and stuff, we always got wood going down, trees coming down. It's not like we're really cutting live things, and we never seem to have a lack of abundance of fallen trees and wood around here. So with just a little bit of work, we heat our house, we heat the outside shop. I'll show that as well. And then you know, but it's one of the best decisions that I feel like we've ever made. So I don't regret it one bit, and if I had to do it all over again, I'd do it. So all right, thanks for watching.